All right, so today we have Professor Claire Belcher, who is professor in wildfire, who's going to talk about her lab, ExeterFire. And Claire, you're going to be talking with other members of your group and
just other members of the university.
Other members of the university. Yes. And that's what I'm really excited about today with Claire, is that she's basically using the GSI for exactly what we're here for. She's using it to reach out to other people in other disciplines, doing other research, practitioners as well.
Anyone who's interested in fire.
Anyone interested in fire and
who starts
anyone who starts fires and anyone who wants to co-produce solutions, basically.
Yes, definitely.
And this is what today is for. We're going to find out more, and hopefully, I'm sure there are going to be collaborations springing out of today's talks. So, thank you, Claire.
For those of you who are also going to speak, if you want to wander around, you can use this one. Or if you want to stay here, you can use this one. I'll probably hold it. Hopefully everyone can hear me. So yes, I'm Claire Belcher. I run the wildfire lab at the University of Exeter, which is a experimental fire testing lab. So we typically work on fire behaviour and fire ecology the most, and we burn things in that lab. But what I'm here to talk about today is a new initiative that I'm trying to start called ExeterFire. And this is going to be in partnership with GSI and also Exeter Innovation, who I've been speaking to about this as well. So wildfire, as hopefully all of you know, is a global systems challenge. Wildfire threatens human life, ecosystems, and critically our race to net zero, because wildfire affects obviously biodiversity, human health, the type of fire that happens, so the behaviour of those fires has feedbacks on things like biodiversity, severity, the amount of aerosols that we have in the air. Anyway, all of these things and more that are listed on this word cloud. But critically, I think what that also highlights is that wildfire is a wicked problem. It's one of those solutions for which there are so many people involved, so many topics involved, and so many actors, essentially, that wildfire, if you consider it a problem, which it is, but it's not always a problem, it's really hard to solve because it's a wicked problem. And the LA wildfires really recently obviously exemplify wildfire as a wicked problem. They've emerged from an intricate web of ecological, infrastructural, social, and climatic factors that have all come together, and it really played out in real time in the LA fires. And this is one part of LA that was part destroyed by one of the large fires burning in LA a few weeks ago. And of course, the GSI is an excellent forum for wildfire because it crosses all disciplines, wildfire, and it crosses social science, it crosses history, economics, life and physical sciences, and engineering. And I think you could argue art and philosophy as well if you want as well. So it really is, it's transdisciplinary and a wicked problem. And I think wildfire is now very much in a very large collective mindset, really over the last 5 years, because we have had these recent game-changing events that we haven't really seen before. We've seen, not pictured on this slide, entirely novel extreme fire behaviour linked to mismanagement of fuels and new climate change and weather scenarios. We've seen fires that make their own weather. We've known they can do this for a while, but we're seeing more and more large pyrocumulonimbus clouds forming, and we've had several cases now where aerosols from those fires and these smoke columns are reaching the stratosphere, so above the tropopause. For the first time in the UK, even in 2022, we saw the first multiple loss of homes due to wildfire. This was in the heat wave of July 2022. And this was just an insane event. As I was watching this unfold, this was not the UK. It's not the vision of the UK that we had. So this shows that fires are now even starting to become an issue in temperate ecosystems that we don't consider very flammable. And of course, zombie fires that burn peat and soil underground over the winter. They burn underneath snow, destroying carbon stocks, a really big climate impact there as well. So game-changing events occurring in wildfire now that affect a broad spectrum of the Earth system and people. So over the last sort of year or so, I've been thinking, so where are Exeter in terms of wildfire in addressing these global challenges associated with fire? Are we at the front of the fire line fighting those? So I started looking, well, I've realised now, originally when I just came here, there was pretty much only me really focusing on wildfire at the university. Then more and more people joined. But over the last 3 years or so, I'm starting to meet so many people that are really in and out of their existing discipline or their study of their research area of focus, and either helping to solve wildfire problems. So I wanted to try to find ways to quantify where Exeter was situated in respect to their wildfire power compared to other institutions. So for my sort of basic search, and that's what I've just shown here, is I went to every university's open access repository and I searched the term wildfire, pulled up the papers and I looked at those papers. And I've put here the other big names in fire within the UK, what were wildfire within the UK. And you can see that Exeter is right at the top in our number of wildfire publications. And I didn't necessarily expect this. I'm very pleased to say that hopefully no one's here from the Leverhulme Centre of Wildfires, but we are above them. And they are a whole centre that is multi-million-pound funded for wildfire research. Above Bristol, Birmingham, Swansea, Edinburgh even, where I used to be quite a long time ago. So this surprised me, and this won't have caught all the fire papers, because actually if you put in fire, you get many, many more. But then I would have had to really scroll through and check that they're all fire, because it could have been like neurons misfiring or something like that, which would have not been really what we were talking about. Anyway, it kind of got me thinking, I think people should know about this. We have a lot of firepower at Exeter, and we need to be kind of telling people that we are ExeterFire. We're not, we're more than our own disciplinary research tunnels that we follow. We're more than that. And here's just a snippet of people in a word cloud that I knew quickly off the top of my head who work on wildfire within the university, but this by no means captures everybody. And that's kind of why I'm here today and why I want to start this ExeterFire initiative. Because first of all, my first phase is I want to build the ExeterFire network. So to draw people together who have interest in fire, you may not work solely on fire, but you may do something on fire. We need to be connected, and we need to connect and kind of describe what our specialities are to each other so that we can build new research visions between us. So that's the first phase of things that I'd like to achieve, is build this network, and both GSI are going to be supporting that, and also Exeter Innovation. And so, for example, what I'm hoping soon is it will be able to add a new little button to the GSI web pages as a research theme that is a specialty of GSI called Wildfire Risk and Resilience. So to do this, I need to start connecting with people who work on fire to deliver a narrative statement for this website that reflects all of our work that we do. So not just the things that I maybe focus on that are most in my head, but also add relevant links to your funded projects, because that shows to the world all the funding and all the types of projects that we have working that include fire within the university. And look out in term 3, I'm going to be hosting some workshops funded by GSI to create us those initial networking opportunities to start building this momentum in what I'm calling ExeterFire. But then hopefully we need to take this further. So we might become ExeterFire internally, but that's not really what it's about, is it? It's not just about connecting ourselves. We need to let the outside know about that graph I showed back here, that people should come to Exeter to ask questions, people who alumni funding or partnerships from industry, etc., etc. They need to come to us. They don't need to come to these other institutions, because we have more firepower than them. So this is what we want. This is what the next phase should be. We want to diversify our research portfolio in terms of the types of funding we can get for different projects. So what I'm planning to do, and this is what I've spoken to Exeter Innovation about, is plan to make a wildfire risk and resilience offering via Exeter Innovation. and also probably via the Green Futures Solutions consultancy route as well, coming through that. So if you're wanting to be part of ExeterFire, I'm hoping that we can build capacity within our specialties to provide advisory to companies, land managers, etc., problem solving, fire risk mapping, fire testing, for example, something we do, via projects funded from diversified income streams and consultancy offerings. So, for example, I've sort of mocked up some web pages just to make you get a bit excited about this. So, you know, some of our expertise might be, and I don't know yet, because this is why we need to create the network to figure it out. You know, these are things that, some of the things that I know me and my team can do. We can help people know the wildfire risks of their infrastructure if they need to know that. We can create wildfire resilient landscapes. We can advise on that. Some other people in GSI can probably understand the economics of wildfire. That's not me, but that's going to be a really big thing right now after particularly the LA fires and everything that's been going on in America and of course other countries. Do people need fire testing? I can assist with that, for example. So do people want to be included as academic experts on a listing who could be contacted through Exeter Innovation or Green Future Solutions, for example? Some of us are already doing this. There's also been a range of expert-led reports, consultancy, expert witness, parliamentary advisory, all going on from various teams that have done these things. So I just want people to know what we do at Exeter and that we are world leading in fire. So my first sort of call of arms for the day is, any of you here or any of you listening and zooming in, because I can't see you, but I think you're there. Can you help me identify everyone who works at fire on Exeter, at University of Exeter? If any of you here in the room or on Zoom, scan this delightful QR code. And there is a little, really basic Excel spreadsheet. If you're interested, put your name on it. And then I will include you in a mail list and we'll start working on this together. If you know others, please add them. I won't email them stuff until I personally ask them. So there's no GDPR issue. I'm not asking for their email address, just a name. And it is all on the Exeter servers. It's all fine. So please do that to help me. So to kind of get you a bit excited about some of the range of things that people are working on, this is just a tiny range of things that people are working on at the University of Exeter on wildfire. I've got 3 additional speakers plus myself at the end to just show you some of the broad-ranging research that Exeter do on wildfire. So Garfield, would you like to come up, introduce yourself and yeah, tell us about what you do? Your slides.
Thank you, Claire. It's a lot of pressure. Go first. And yeah, awesome. That initiative that you're trying to build, a group of collaborators that make it easier for us to showcase not just the collaborative nature of research, but also just the integral necessity for that collaboration to address difficult problems. So I'm Garfield. I am a marine biologist, comparative physiologist by training. I didn't start off in fire, but I grew up in a fire-prone area. I have a PhD in San Diego. I grew up in Los Angeles and Davis, California. So I'm pretty, the LA fire has been pretty close to home for me. And I'm currently a Marie Curie research fellow here at the University of Exeter with Rod Wilson. And I'm mainly working on research on otoliths, things that are not related to fire. But part of my specialty here is to understand how an animal responds to external conditions. And wildfire ash input is something that I started back in my previous postdoc, back in Davis, California. And this led actually to work with Rod Wilson and has since grown into work that is built off of the QX initiative here, partnership between the University of Queensland and University of Exeter. And we're currently looking at some of the impacts of wildfire ash on early life aquatic organisms. So I want to break down a little bit of what we're doing and kind of generate some interest in the room and also showcase just the biological influences and in the biology realm and how that links to the wildfire ash work that Claire and others are leading. So fires happening around the world. Claire highlighted quite a few. Got some in Australia. You know, it's Australia because it's a kangaroo. United States is not just the LA fire. This is actually Hawaii fire. Caused a lot more deaths, unfortunately, there. Canada's been burning, and also the UK heatland fires. And my focus is not simply the fire, but what happens after the fire. There's a lot of attention on the fire, but when it rains, it pours, and all of those landslides that happen, and all of the ash and fire retardants and pollutants and urban runoffs move into the water. And here's some pictures. One recently from the LA River. I found this morning, and it shows just how much output goes into these water systems. We shouldn't call this the LA River. It's kind of like gutter anyway. It's dry most of the year, if not all of the year. But the other rest of the world, there are areas that are migratory pathways for salmon, usually shaded, now inundated with dead vegetation, burnt foliage, and lots of debris. How does that impact the organisms in that system? How does that impact their olfaction and the migration patterns? How does that impact the early life stages, endangered species, endemic species? So these are all questions that back in California, I was really curious about and started my work on it. And some of the work that has led me to just look into the downstream impacts. So you have salmon, rainbow trouts, climate suckers. They don't perish at the site of the fire. If you look at the background of these pictures, you can see green vegetation. These happen downstream of the fire. This happens away from that site, and this happens weeks, months, maybe even years later after the fire. So these are all not just the unique nature of the questions that I'm asking, but also presents unique solutions for these questions I'm asking. For instance, if you're a manager that is trying to conserve these species, perhaps you can look at the area and know and predict like that these animals that are migrating back are going to be hit by an incoming storm. You can capture the fish and move them to a different stream. There are conservation aquacultures that are in the States that can do this. So some of these ideas can be applied and be used for conservation and management of endangered species. This is just to highlight anecdotally that the mortality comes after a rainstorm, not just the fire, but after the rainstorm. So there's a combination of factors that lead to these mass die-offs. So some of the ongoing research that we're doing is to understand, first of all, what's causing the mortality. So one of the things I want to highlight to people is that ash runoff can change pH and alkalinity. And organisms have to not just live in a very narrow, like somewhat narrow range of water pH, but also to be able to tolerate rapid adjustment in that pH and alkalinity. And so this is just to give you an idea of how big of that change it is. So this is back in UC Davis, well water that was at 8.0, and the more ash you added, the higher the pH. So 0.25% is what I highlighted in that orange bar. And 0.25% weight by volume is the equivalent of, and sorry for my American imperial system, I guess I'm talking to Ritz, but 2 teaspoons in a gallon of water. 2 teaspoons of ash in a gallon of water changes your pH from 8.0 to 9.0, 9.3. And this is in really well-buffered, alkaline, hard water. So this is just an idea of how little ash can dramatically change the pH of the water. And that has led to about a 20 to 33% mortality in healthy juvenile Chinook salmon. So this is just this kind of like a representation of the US fires, chaparral environment, and also representative of just Australian fires. Another paper was published on that as well. But the UK has a very interesting scenario where after a fire, it's been recorded to actually decrease the pH of the water. And what we are now understanding more and more so now is that it's not the ash that's causing that pH decrease, but that when you burn off the vegetation holding on to the peat, the runoff leads to greater acidification, leads to greater peat input, peat impact on the water system. And potentially the ash might be dampening that pH change, but there's a whole lot to understand here. So what we're currently doing, supported by the QX initiative, is to understand how early life stages are impacted by the two types of ash and wildfire and peat. We're looking at zebrafish, rainbow trout, and another Australian species to understand how simply exposing them to these wildfire ash input is impacting their sublethal and where their lethal endpoints are. And we're trying to understand the water chemistry behind it, trying to understand what kind of pollutants are potentially causing these mortalities, even though the pH, all the toxic metals that we've looked at so far is well below the LC50, where seeing mortalities happen. So this is just a list of the collaborative effort that I've accumulated thus far. So these are people that probably can fit on your list as well. So this just to give you an idea of what we're currently doing. And if you want to read more about the work that I've done, here's what the paper looks like. So thank you.
So much. I'm hindering Garfield's work so far by failing to produce large enough volumes of ash in the lab for him, which you wouldn't think making ash was hard. But anyway, so next up, we're switching gears to Remy Vandal. Remy, would you like to come up and talk us about your digital twinning and wildfire risk?
So, hello everybody. My name is Remy Vandal. I'm a postdoc here at the university at the Joint Center of Excellence in Environmental Intelligence. And my own background is mostly in machine learning, especially in computer vision. But yeah, today I'm going to talk to you about a project that I've been working on, which is about extracting wildfire information in order to assist multi-objective land use decision in UK green belts. So to give you a little bit of background, green belts in the UK are areas surrounding big cities, and so embedded in national policy planning, where the idea is to keep these areas green in order to prevent urban sprawl. So there are about 16 of these green belts in the UK that cover 12% of the land area. And of course, in the context of climate change, they play a very important role, which is why there is a lot of pressure to try to optimize their use. And this is where the project on which I'm working comes into play. So the idea comes from the Met Office, where the idea was to build a digital twin demonstrator called Quest, which, as you can see here, the idea is to try to have as much information as possible in order to optimize land use around green belts and understand the impact of potential changes. And so the GreenSight project works on providing two types of information: carbon dynamics, which is not the topic today, but also vegetation and wildfire information. And so in the context of the project, the idea was first to try to build a record of wildfire in the UK in order to try to identify in the green belts where such fires are happening, and also which are the trends over time, to try to better understand what's going on. But we also want to try to analyze the sensitivity of some land cover types, depending on the sensitivity of land cover types to wildfire, in order to integrate this information into the digital twin. And so in order to do that, so the first thing that we did was to try to build a dataset. So what we used first was the FIS dataset that processes satellite images from VIRS and MODIS. And with that, we have access to shapefiles. But as you may know, only the biggest wildfires are recorded in this database, which is why we are considering other types of database. So the Dorset Fire Intervention dataset that we have obtained thanks to Claire. So we have a larger record of shapefiles and wildfire locations thanks to that, but we are only limited to the Dorset County. And we are using now a new dataset, which I've started using since last week, but which is the Fire Statistics Incident Level dataset, where we have much more fires that were recorded. So this is a database from the Home Office, but we don't have access to any kind of shapefiles. We only have access to LSOA location, which is basically like postcode location. So we don't have the accurate location of the fire, but we know the surrounding of this fire. And so, yeah, in the first time, what we did was simply try to see the trends over time and the importance of wildfires in the green belts, to try to see where they were happening in the green belts, but also the trends. So if we had a larger number of fires in green belts, but also when they were happening, and if it was any different from what was happening in the UK overall. And so after that, so what was the most important part here was to try to map land cover to the fire that we obtained. So the idea was that we used the shapefiles from the EFIS and the Dorset Fire Intervention dataset that we try to map with the UKCH land cover map, which provides 21 land cover types, but also that is used by the Met Office through a crosswalk table where they use their own land cover types. And also the ALC land classification map, which is another map where the land is classified into 5 grades of farmland quality. And yeah, the idea here was to try to see on which types of land cover the fires were happening in UK green belts especially. And as you can see here, for example, most of the fires that we see in the green belts are happening on heather category type of lands. So using the crosswalk table, we have also tried to plot this kind of graph using the joules land cover types. And finally, we also did that with the agricultural land cover. Yeah, for those who don't know, so joules is the land surface simulator from the Met Office, so which is why we are trying to have these types of land cover by these statistics by land cover types from the joules. And so we also tried to plot this according to agricultural land cover types. And now more recently, what I'm trying to do is to try to use machine learning to estimate wildfire occurrence in LSOA, so using the Home Office database. So here we have about 1.3 million fire incident records in the UK since 2013, where we have for each incident LSOA location, and we have 15 types of categories of fires, as you can see here on the right, with some that are more represented than the others. And what we try to do is to use a machine learning problem where basically one observation is a LSOA that is described by the histogram of UKCH land cover types within the LSOA and the area of the LSOA, and we try to output basically the number of fires per square kilometer within the LSOA using a random forest model. So here the goal is really to try to see which mix of land cover are going to provoke fires within this LSOA in order later to try to bring that model within the digital twin. So this is research that are really in progress for the moment. So what I've done until now is simply compare myself to random input instead of using the UKCH histogram. And here you can see on the y-axis the error. So you can see that we have some improvements using this land cover types when compared to a random baseline, but I think we can probably improve that later. So yeah, basically, this is our work on wildfire for the moment. What we're trying to do in the first time is to try to improve the machine learning models that I've shown you. So bring more input types within the description of these LSOs to try to have a more accurate models. Maybe also try to restrict our models to just green belt LSOs, as this is really what we are interested in. And also in a second time, what I would like to really do is also record more records of fires in the UK, especially by investing the potential of using Sentinel-2 data, using novel geospatial foundation models, try to detect burn scars on these types of images. So yeah, that's for my work.
Going to keep plowing on. So next up, I've been thinking afterwards you can ask questions or grab people at the end and ask them specific questions perhaps. So next up we have Stephen Sitch, sort of on behalf of Stephen, Jim and me, because I snuck in a slide.
Yeah, great. Ooh, does this work? Okay, good. Yeah, so this is actually mainly Jim's presentation. There's also Lizzie has contributed a lot to this, and Claire and others. And it's linking fires and impacts in the atmosphere. Okay, so this is very much your work, isn't it, Claire, in terms of how you have the different burning leads to different grayness of the smoke. And that's linked mainly to to a large degree, the amount of black carbon fraction. So you can have flaming combustion, so high black carbon content, so more absorbing in the atmosphere, smoldering combustion. And so you've got the emissions themselves going into the atmosphere vary depending on sort of environment. And that's the type of work. I'll give an example from Claire's lab near the end, where you're looking at some of the emissions related to environmental variables. But what actually happens then in the atmosphere? So here's a good example. So you imagine you have the Earth's surface, you have a dark ocean surface, doesn't reflect very much, absorbs incoming solar radiation. Or you could have a cloudy day, or a snow surface is bright, a lot of reflections, so high albedo. And then you have the fire coming along. So you imagine you have a fire, the plume over a dark surface. So essentially the dark surface becomes essentially lighter. So that means you have an increase in planetary albedo, negative what's called radiative forcing, i.e. a cooling of the planet. But if your plume goes over snow or over a cloud, it's the opposite. So now your bright surface sort of appears darker. That implies decreased planetary albedo, positive radiative forcing, and warming of the climate. So essentially, when you ask the question, what's the impact of the emissions, the aerosol emissions associated with biomass burning, you first need to know what type of fire it is. So what plume do you have? How high does the plume go? And does it go above which surface? So you need to know the meteorology and the location. Okay, so this is Lizzie's work. So here's looking at the climate impact over the sort of California megafires of 2020. And so the two examples here, you see the planetary albedo is enhanced over cloud-free oceans and dark forests. So that would lead to a climate cooling. Whereas you have reduced albedo over cloudy regions and a warming. So you really need to sort of know your climate, your meteorology over around the fire event itself to get an integrated picture in terms of the impact of the fire on climate through the aerosols. Okay, so that's something we're investigating in a European Space Agency funded project called ExeterFire, which I'll come to right at the end. Okay, so Jim wanted me to show this video. So he's not just the modeler, he's also taking sort of data from the UK FAM aeroplane here. It tends to fly low, for a lot of weather, a lot of turbulence. You wouldn't see me dead in that. But you can see the sort of transects over equatorial Africa. So, it's not only modeling, it's also taking measurement in the atmosphere to understand the properties of these plumes and the heights, etc. Okay, so now a paper, Claire is co-author, Jim and others, and it's looking at the impact of the sort of mega fire over Australia in 2019. So you see the smoke coming off the coast, you see the area impacted by fire. And essentially the key here is, for Jim, is how high does the plume go? So if the plume gets into the stratosphere, that has really big impacts on climate. And that fire did extend into the stratosphere. So now, if you look in terms of the impact in the stratosphere of this smoke, you can see this is the temperature anomaly in the stratosphere through time. And you can see the Australian fires, they reached the stratosphere, heated up the stratosphere, and that was the biggest sort of heating of the stratosphere since the Mount Pinatubo eruption in June 1991. So the big impact is this slide, really, is you have the heating and then you've got the chemistry within the atmosphere, in the stratosphere, and that's essentially leading in 2020 to a recurrence of the ozone hole. So you imagine the whole climate debate, you know, you have the Montreal Protocol about CFCs because we had the ozone hole, but what happens in the future if you have mega fires which reach the stratosphere, which effectively do the same job as CFCs? So you can unravel the whole Montreal Protocol with just sort of mega fires reaching the stratosphere in the future. Okay, so yes, there's two projects we're sort of referring to. One led by Jim called, it's a NERC-funded project called Twister. So Claire's involved. So you see Claire's lab here on the left-hand side, and that's looking at sort of the properties associated with eucalyptus, so fire radiated power, aerosol absorption. And then that information goes into the next component, which is the plume modeling. So how high the aerosols reach in the atmosphere. And then there's the sort of atmospheric modeling in terms of chemistry, etc., and impacts on the ozone hole in the stratosphere. And finally, looking at future projections, etc., for simulations. My final slide is just highlighting our ESA-funded project. So that's Jim and I. So I'm the lead of this project, but it's essentially looking at multiple work packages. The first is to define and identify extreme fires. And in fact, Claire and colleagues have a paper on this in terms of mega fire description. And then the idea is to use what's called essential climate variables from space to try to model extreme fires as opposed to normal fires, and essentially use machine learning to understand relationships of these extreme fires versus these environmental variables. And then to look at the impacts, first is in the atmosphere. So that's my link with Jim. So Jim's working on running the climate model for some of these extreme fires. And then there's also other aspects. So there's one which is looking at the impact of extreme fires on water bodies from space. So there's actually quite a nice link to the earlier talk. So it's actually trying to see, can you see a change in color of lakes, etc. So it could be sediment load, could be algae, etc., etc. There's also then impacts in terms of cryosphere changes. So black carbon lands on the ice sheets, potentially they melt faster. Cool. So it's back to you.
That's Stephen and Jim there as well. Yeah, it's quite ironic, really. As I said, I can't produce enough ash for Garfield, but the problem in the lab at the moment is Stephen showed Jim's equipment on an aircraft. So he has brought the aircraft equipment to my lab, and now it's trying to measure the aerosols from right next to the fire. So I can't produce enough ash for Garfield, but I'm producing way too much aerosol for Jim right now. So we're trying to dilute it. So yeah, matters of scale are challenging in experimental science. So finally, a bit from some of the research I've been doing. I'm just going to show one thing that we've been working on as part of a big project between several universities, including Manchester, Birmingham, Swansea, particularly, and obviously Exeter, where we've built a web-based fire behaviour prediction system for the UK. So a bit about the UK, you've heard a bit already. So the UK has a pretty complex fire regime, actually. We're not having these giant mega fires by any means. But we do have quite a complex regime of management burning, and this episodic wildfire, often dominated by smouldering, as shown in the picture here, because this is a peat fire, Saddleworth Moor fire. The UK has a mix of land cover types, as Remy noted, where the UK's heathlands and moorlands are actually typically the land cover types that have the largest burned areas in the UK. And they are often underlain by peat carbon stores, hence they contribute to obviously carbon into the atmosphere and are a bit anti-net zero. So fires in the UK typically occur at what we call the rural-urban interface, creating distinctive fire challenges, because we have this quite small patchwork of landscape across the UK that puts people, property and infrastructure actually very close to not true wildlands, but flammable pockets of land. And so this obviously not only impacts human life, property and infrastructure, but also land assets and causes ecological disturbance. And if we make predictions into the future, this is some work we did a while back, but this actual graph is produced by Matthew Perry at the Met Office. These were some future predictions of fire weather in the UK. And if we look at the worst case scenario, which is 4 degrees global warming, our summer, particularly in the south, could have as many as 50% of the days in the summer as having a very high fire weather index. So if we kind of look at where we're at, you know, somewhere here, it gets actually quite a bit scary, and particularly a bit scary where a lot of people live. And I've drawn a picture here of all the major road network coming out from that. So it really does impact our infrastructure. If you want to look at that, you can, any papers and things that are published are on the QR codes on these slides. So currently, the UK does not have a fire danger rating system. So some of you may be familiar with what these are. They're kind of that low risk through to extreme, and now even more, I think, in some countries, sort of this dial, usually shown as a sort of traffic light-ish system, which suggests, at least to local people, the chances of a fire starting and leading to dangerous fire behaviour. But what underlies that is much more information that goes out to fire and rescue services and land managers about what infrastructure they might need to start putting in places. And the UK doesn't have one of these systems, and it also doesn't have a system that enables fire behaviour to be predicted. And when I say fire behaviour, I mean the rate of spread, the intensity of the fire, and the flame length. And this is essential to know because fire and rescue services and also land managers need to know what the fire behaviour is, because it determines the infrastructure needed to fight any resulting fires. And so I've kind of shown a little schematic about what the law is for the UK. You can directly attack as a person flames up to 1.5 meters, which is roughly my height. But you can imagine that's quite scary, actually. If I was a fire burning at you, it would be, you know, quite a high temperature. And as once we get bigger, you only need flames to be bigger than 3.5 meters to need aerial attack, potentially. We have no aerial firefighting equipment in the UK. We have to borrow helicopters or hire them. So just so you know. But so we need to be able to predict fire behaviour and give that as a system to fire and rescue services and people so that they can be better armed. So over the past 4 years, as part of a NERC-funded project, we've built such a system. Hooray! So I'm going to show you some of this system and how we've got to there. This is a snapshot of the web app that we've built. So it's called Fire Insight. It's a fire behaviour prediction system in the form of web-based application, and it forecasts the probability ignition, surface fire rate of spread, flame length, and fire line intensity for a user-selected location over a set of UK fire-prone vegetation types. Hopefully you'll see that it's an easy-to-use web-based application. It takes weather forecasts and it can predict fire behaviour at the moment for up to 7 days, which we're increasing the capacity of that, and also currently we'll hindcast back to 1950 as well. So if you want to look at previous events, you can actually use this tool to go back and look at what the previous fire weather was, what the previous fire behaviour would have been or was in areas. So before I show you the system, I realise this is a bit of a crazy slide, but I just couldn't bother to put it on lots of slides. So this is what basically the model looks like. It basically takes topography, weather, as you would expect for a fire prediction system, And then we've built these modules that all feed through to a fire behavior prediction system. So what we've done, we've looked at over the last, forget how many years this is, probably 20 years of data of the phenology of fires. So this one here, if anyone can see, this is the UK CEH land cover types. And what we've done is we've looked at the satellite VIIRS-based data of fire occurrence for different vegetation types through time for different areas of the UK. And you can all see where those peaks are. That's when the major fire season occurs in different areas of the UK. So this is north, east, south Scotland. Then if we move down, this is the northwest. But as you can see, the south starts looking a bit different. So fires occur at different times in different parts of the country. Some are more to do with fuel state, and others are a combination of fuel state and fire weather. So we've kind of programmed this knowledge, so to say, into the model so that it understands that side of the phenological risk of fire. We've then taken 2 years worth of fuel moisture data, no, 3 years worth of fuel moisture measurements taken from 43 sampling sites over the UK to build live fuel and dead fuel moisture models that sit behind the fire behavior system. We've then looked at samples, we've taken fuel samples from 5 moorlands, 5 heathlands, 12 forests across the UK for over a year. Some taken twice monthly, one taken once, some taken once monthly, to look at basically the phenology of flammability of fuel samples. So this is this is how quickly samples typically ignite of some different fuel types. This is January, this is December. You can see when ignition is quicker or slower. So slower here in the summer in most of our heathland fuel types, for example. And then this is the amount of energy they release, because in the model, you need to give your fuels amount of energy held within them for the equations. And this is a special UK-specific heat content system. And anyway, whatever, you don't need to know so much detail about this, but we've basically designed at least 7 overarching fuel types that you can run at the moment. This is being expanded. If you want to look at any of the resultant papers thus far, you can look at the data sets in those QR codes. I think this is being recorded, so you come back to it. So I'm now going to attempt to just kind of walk you through what Fire Insight looks like, because I think that's more interesting than me just rambling away. You can try it for yourself while you're here if you want by typing that in or screening that. It should work on your mobile phone. Hence, it can work for firefighters in the field. So I'm just going to come out of this because I did attempt to put it here. Now I need to stop sharing that and reshare this. Hi, everyone. There. Now, I did notice the web was a bit slow in this room earlier. You are right. So hopefully people can see that online. Let me go out the way. So this is what Fire Insight looks like. This time of year is the worst time of year to demonstrate this. So as you can see, currently it knows where we are. So it's deciding to try and predict fire behavior for the university. Somebody's put something in the chat. Oh, you just sharing it. Cool. And there is no fire behavior to predict, as you can imagine. It's been pretty wet. So what normally will come up is some graphs here. And then it's taking we can see the weather, we can see the temperature today, the relative humidity, when it's rained, what the wind speed is, when the gusts are. Now, what I'm going to do then, because it's January and has been raining, I'm going to demonstrate the functionality of, let's go to historical, when we have a much more flammable time. I'm going to journey back to the heatwave year, July 17th, 2022. Might be a bit slow because the web seems to be very slow in here. We have some fire. We can even go, hopefully, to where those houses were destroyed. So basically, while I'm scrolling around this map, what I do, if I go here, so it's somewhere around here, where I click, it's taking the weather for the closest weather station, the topography, and that altitudinal and slope data automatically. At the moment, it doesn't know what fuel's there, because usually if you were a fire service or somebody else, you know what the fuel is near as type. So what it does, it predicts all the fire behaviour for the typical fuels that burn in the UK, and these are these fuels. So these are 4 different types of heather. So low load through to very high load heather, so different heather heights, and it's producing you different fire rates of spread. Then we've got mixed heath, which would be typically the Dorset heaths, gorse, probably our most flammable plant, different loads of grasses and leaf litters as well. It's always a bit handier if I show you the flame length predictions. So on that day, we could have had up to 3 meter flame lengths. You saw destroyed houses. So these are what you can show that it works quite well. If you want to look in more detail, you can look at this hourly. So of course, if you were a firefighter on this day, you would have been wanting to, if you got up on Sunday, 7 a.m., you would have been wanting to look at when the fires were going to be later in the day, because that's when fires are worse. You can see it's then giving you all this information on an hourly basis of what the flame lengths would likely be on that in the area that you're at. If you want to find out more about what fuel it looks like, this is what you might be looking at, and it gives you all the parameters of that model as well. So yeah, I don't want to go on too long because I realise you've all been listening for a long time. But yeah, if you want to read see more about Fire Insight, read the About part. We've got tutorials. You can learn about the fuel models that are all in there. They're in a lot of detail. If you want to use them in your models, they're there as well. You can just copy them straight out. But yeah, hopefully this is going to improve fire and rescue services' ability to know what fires are going to be fighting in the UK. We've been working with the UK Wild and Fire Tactical Advisors, who are part of the Fire and Rescue Service, and they're all really positive about this and that it can be helpful. So I'll leave it there about Fire Insight and just return to my slides, because I want to just come back to, please do add your names, share this with other people, please. Let me just move that out the way so that people can get to your QR code. Because if we want to create this network and start getting ourselves out there to the world, we need to be able to let them know. So I need to know who all the people are at the University of Exeter that work on fire, so I can start working on this with Exeter Innovation. So, well, thank you for everyone who's presented today, and if anyone's got any questions, feel free to go ahead and ask any of us or grab us afterwards. Thank you.
Fantastic to see many speakers in one go. Just about the link, if you don't have permission to edit the SharePoint, you're welcome to just shoot an email to info.gsi at Exeter.
Well, it should work, but is it not?
I don't know, some people on the chat online have not been able to
I
get
guess
in,
they need
but
to be signed into Exeter's.
you need to be signed into Exeter.
Your Exeter account, and then it should be, so anyone within the organisation can edit it.
Okay,
So
cool.
if you're not signed in.
But things have been popping up in your spreadsheet, so that's
Cool.
great news.
Awesome.
Right, any questions?
Yeah, thanks for all the really interesting talks. So Garfield, I thought your work was really interesting. I was just wondering, have you done any experimentation around things like the degree of burn severity of a fire, or something like time since last fire, and how that then relates to the potential degree of impacts on aquatic organisms? Sorry.
Thank you. So I think the question that's caught me off guard was time since fire versus impact on organisms. The quick answer is no, because no one has really looked at the acute physiological responses that I've been examining. We had to work a way around getting ash from wildfire prone area in California. They don't exactly let you into wildfire burn areas. So we have to create control fires and collect from those. So, and estimate with those to compare to observation data. But what you bring up is a really good point. There's a lot of work to be done in this field. Anything you can name, different regions, different soil type, different burn severities. All of those can have an impact on water chemistry and downstream impact on organisms and food web. And it doesn't have to be just fish. It can be amphibians, inverts, it can also be coastal, ocean, things like that. So yeah, thank you.
Ooh, online, Reza is asking, what is the projection on extreme fire frequencies or other extreme weather events in the next decades? What's the projection on the frequency of extreme fires or other extreme weather events? I guess related to
on
fire.
extreme fires or other any particular location?
Reza, do you want to elaborate on your question? Can you unmute? Feel free to speak out.
Sorry, yes, thank you. This question was raised by one of my colleagues in terms of global frequency of extreme weather rather than the intensity. I assume that it is the case that they are both related to each other, but just to confirm from you that this is indeed the case, that the frequency is also increasing as well as the extent of the extreme weather.
I'm not even really sure. We're definitely getting more extreme fires, but I don't know what extent to all of those are really linked to just climate. I think if you're interested, have a look at what's his name? Mark Castellano's work from Spain. He has quite a lot of information on the linkages between extreme fires, which is partly fuel driven, but also some of the different weather phenomenon associated with climate change that those are making. So I could sort of point you in that direction if that's of use.
Yes, please, in the chat. Thank you.
Oh, there is time for maybe one last quick. I don't think we've got one online either. Okay, great. Well, stick around for coffee and tea and biscuits afterwards to chat with Claire and with everyone who gave talks. And yeah, thanks everyone for this super invigorating, well, for me, introduction to wildfires. Really interesting. Thank you.
Thank you. And then I'll reply on the chat.